Hello, my name is Akhil. I'm going to talk about the main cloud features that we have implemented in our project. The first one being resource pooling. Resource pooling is done through our Docker manager, which is set up on VM1. How it is done is when any particular request comes through to our request API, that is through our Flask API, say for create user, create function, or any of our 7 main microservice calls. Say you have to create one microservice or say 100 microservices. The Docker manager takes care of scheduling these microservice calls, creating it, and removing the same microservice once the microservice job is done. Hence, resource pooling has been done to Docker Manager. The second most important point being broad network access. We have implemented broad network access. We have provided for broad network access through our REST API, which can be accessed by any client. We have shown the same through our custom Python client, which we have built for bulk request calls. And additionally, we have tested most of our application through Postman application, which is a Chrome application. And the third feature, that is on-demand self-service. That is right now, consider execute function, a particular function where a user has created a Fibonacci function. In our particular architecture, he can give any input data set that is from a number from n1 to n to 1000, and it can be any number between any number of inputs. So say he creates 10 functions with different input sets. Once he requests So once he requests for an execute function call for any of the four data sets, our REST API makes a call to the Docker manager. And the Docker manager schedules the microservice with respect to the given data set by fetching the function from the DB and scheduling resources when required and removing it when it's done. So say the Fibonacci function is for n of 5, then the microservice is going to run for less than a second. But say if it's for n of 1000 or 10,000, then the microservice is going to run for a long time. Hence, the user does not have to worry about the amount of time the function executes, the resources required. Everything is handled by our Docker manager by scheduling it on any free VM, that is VM1, VM2, VM3, and VM4. Hence, we have achieved on-demand self-service to this. And rapid elasticity. Again, as I've highlighted my point before, Docker Manager helps us with scheduling a microservice, and then microservice can run for any amount of time, depending upon the input set, like a Fibonacci, like the previous example I've given, the Fibonacci sequence. Depending upon the number size, it can the execution time could be less than seconds or could be minutes, and the required resources can be pulled can be pulled from the Docker manager when required and can be rescheduled when not required. Hence, we have shown the major features that require in a cloud architecture. That is one, resource pooling; second, broad network access; third, on-demand self-service; and fourth, rapid elasticity. Uh, so now I'm going to show you an execution of execute function. That's our core functionality. For example, here the function would be a fib iterative function. You have to declare all the functions as global if any function is being used outside our MADHat function. A MADHat function accepts input data and output data. Input data would be whatever data that could be passed as a JSON object, and output data is whatever data that you want once the function has been executed for your self reference. So if you look at it, here you have your fib iterative, here you have the global declaration, then here you have a simple output, and here you have a call of fib iterative, which is again getting stored in output. So now here, if you look at it, we've already set up the system in our Toto lab. This is the input data. Input data is a JSON object. It could be any key, any value that can be used by the user. And similarly, he can expect any output outside. All you have to do is execute the same as illustrated. So now once it's executed, the Flask API gives us back a request ID. Request ID. This how this works is once a user requests for execute function, the execute function creates a container, and when it creates a container, it gives back a request for this particular container. The user has to poll on this particular request to get the required results of his requested function. So now if we take this particular request ID and put in our check request status, which is another function that we provide to the user. You'll notice that the function is still running. Hence, it is still showing us container is to be spawned. Once the function is executed, we can witness the output and the output data for the particular function. So if you have a look at it, this is a sample output for a particular execute function. These are the request parameters that we sent. This is the input data we sent them. This is the output text, that's the print data inside MADHat, and the output data is the Fibonacci values that we sent. So hence the user can get the printed output and the output data requested. This is a sample function of Fibonacci. The user can execute any function that he desires and get any output that he desires.